Hello everybody and welcome to the Callum Cymru revision sessions. The session this evening will focus on GCSE mathematics and will be presented by Mr John Casey from Pentre School in Swansea. The session will last around 45 minutes where Mr Casey will run through the relevant content. If you have any questions during the session, please use the question and answer section and we'll do our best to answer you. Before the end of the session, you will see that there is a hyperlink in the question and answer section. If you're happy to leave your name and email address, we would love to keep in touch with you so we can send you information about future events. You can click on the link at any time during the session. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Callum Cymru tab. Thank you, Mr Casey. Over to you.
Okay, thank you, Mrs. Dixon. Okay, we're going to make a start. So today's lesson is sine rule, as you can see on the screen. So this is a higher tier GCSE session. It may be worth you looking at the previous session we did on right angle trigonometry, which is one of the intermediate sessions, but those questions could also go up a higher. So it's probably worth taking a look at that lesson sort of prior to completing the lesson on sine rule. Okay, so let's have a look at what we're going to try and cover over the next 45 minutes. So we're going to try and look at the formula and the sort of explanatory notes on the formula page to understand what the parts of the formula actually mean. Then we're going to have a look at the sine function actually on your scientific calculator and just sort of go through how that works. We're going to use the sine rule to find the missing length on a triangle, and then also use the sine rule to find the missing angle. And what we'll do is we'll practice some GCSE questions to get used to the sort of structure of those questions and how those questions will be presented on the exam. Okay, so let's have a little chat about the sine rule then. So in a moment, we'll have a look at what the sine rule is and where to find it on the formula page in your exam. But I think the thing to remember is the sine rule is used to calculate sides and angles in some triangles, and generally triangles that don't have a right angle. So look at these two triangles here. The one on the left-hand side has got a right angle marked in the corner with a little square, as I'm sure you're familiar with. And you'd use the sort of SOHCAHTOA, so the trig ratios, to find missing angles and sides on that sort of triangle generally. And like I mentioned, that's in the previous video. And then there's a normal triangle, like a scalene triangle on the right-hand side, is what we'd use the sine rule for. So not right angles, but it is sort of the other type of triangle that we're going to focus on. Okay, so where would you find it? So a lot of people, unfortunately, a lot of pupils I've taught sometimes ignore this page, but there's lots of useful information on the formula page. And in particular, we're looking at the bit that I've just highlighted in red there. And the bit that we're looking for is the sine rule, which is A over sine A, B over sine B, and C over sine C. So it looks quite tricky. A lot of information shown in that rule. But what does it refer to? So again, there's another bit of help on the page for you, and it is this triangle that they've drawn. So this triangle, you can see there are uppercase, so there are capital A, B's, and C's, and there are lowercase A, B's, and C's. And we're looking at this, you can see that the little a, the little b, and the little c are marked on the sides of the triangle, and the capital A, B, and C are marked in the corners, so they'll represent the angles. And that's the same for the actual formula above. So we can see that it's little a over sine A, little b over sine B, and little c over sine C. Now, the important thing to mention at this stage is there's kind of three parts of the formula on the formula page, but we're only ever going to use two of them. So, we're only going to be finding one angle or one side as an individual question. So we're only going to be using two parts. So, for example, I could use A over sine A equals C over sine C, for example. So we only use two parts of the formula, but we'll come on to that in a moment. Okay, so you got your good old calculator, your good old scientific calculator, and you may notice the buttons at the top. You may have used these before, but to use the sine rule, we're going to be using the sine function there for the sine rule, which we'll be using in a moment. Okay, so let's take a look at an example. So I think we're going to do a few questions on finding the side first, or finding a missing side. And then after a little bit of practice, we're then going to move on to finding a missing angle. So let's have a look at what we've got. So look at a triangle here. We can see that I've marked the sides A, B, and C. Oh, excuse me a second, just trying to get my pen working. Oops, it's all going wrong. Let's go back one. Okay, I apologize. So let me get my pen. There it is. Okay, brilliant. Okay, so I've marked the sides, I've marked the angles A, B, and C, and then that side B is marked on that left-hand side of the triangle. Now, it says here, find the length of side B. So here's really my top tip for this. Whatever you're finding needs to be on top of the formula. So we're finding B, so I'm going to do B over the sine of B. There's a little bit of a lag on my pen, you have to bear with that. I'm writing this appearing a second or two later. So whatever I'm trying to find, I'm going to write first. Now, I need to look at the question now to see what other information am I given. So I'm looking at angle A here. There's nothing there marked for angle A. And the opposite side, which is side A, there's nothing marked there. And I didn't mention this earlier, but it's worth mentioning now. The capital A's are always opposite the side A, capital B opposite side B, and so on. Now, I'm looking at angle C, which is 46 degrees, and side C is 17. So I'm going to use that information. So I'm going to put equals C over sine C, and that's kind of my starting point. Now, I'm probably not going to write that formula out every time. I'm probably just going to use the numbers at the start, but it kind of gives you an idea of the original formula on the formula page, which was in 3 parts. I've now only used 2 parts of that for the information that I need. Right, so let's change some values. So B, I'm just going to leave that as B for now, because that's what I'm trying to find. The angle B is 73 degrees, so I'm going to change that capital B to the sine of 73. And then side C is 17 centimeters. I'm going to change that to 17. And then sine C is sine of 46. So sine of 46. Which is there. I haven't written that very neatly, but that does say 46. Now, like any sort of problem I'm solving in maths, whether it's an equation or a lot of trigonometry questions, I'm trying to get B on its own. So to find the value of B, I've got to try to get it on its own. But at the moment, it's divided by the sine of 73, which I don't want. So what I'm actually going to do is multiply both sides by the sine of 73. Maybe easier for you to remember that the sine of 73 moves diagonally upwards. That's the way some people teach it. So what I'm going to type in my calculator to find the value of B is 17 multiplied by the sine of 73. And then all of that is going to be divided by the sine of 46. Now that's pretty much how I'm going to type this into the calculator. I think what I would probably do is type in the top line and maybe press equals and divide it by the bottom line. If you're comfortable with your calculator, you could use brackets. But it is really important before the exam that you have a full understanding of how your calculator works. So I'm going to type it all in the top line. I'm going to press equals, divided by the sine of 46, and then I get an answer of 22.6, and the units, of course, are centimeters. And I have rounded that to 1 decimal place. So I should write 1 dp in brackets. Just really quickly before we move on, does that make sense? If that side is 17, could that side there be 22? Yes, of course it could. The numbers kind of make sense with the question, and always have a quick check of that to make sure that the answer that you've got is a reasonable answer. Okay, example 2. Now, the problem with this is there's no A, there's no B, and there's no C. So it is a bit of an issue. So what I've just said to you about the formulas, you can't really use, but what you can do is kind of adopt the formula to fit the question that we're finding. Now it does say there, find the length of LM. So let's have a look. From L to M is this bottom length here. I can leave it as LM. That's absolutely fine. Or my pen keeps disappearing for some reason. We try and get that back again. Oh, there it is. Okay. So LM is this bottom length here. And I think for the purpose of this question, I'm just going to call that X. I'm going to put an X there. I'm going to leave the LM as X, and I think that's going to be easier to show my workings. So I'm going to put side X opposite angle. The angle is opposite that side. So let's have a quick look. There's LM. The opposite angle is 44. So X over the sine of 44. And then what other information have we got? We got this side here of 26. So I'm going to write 26. And the angle opposite that is 108. So I'm going to put the sine of 108. Now, some of you may have noticed, and I was certainly going to mention it later, the sine rule is all about opposites. Yeah, the side opposite the angle, the side opposite the angle again. So I'm looking for opposites, so I'm using the sine rule. If we haven't got opposites, then maybe I may use something else, which we'll probably discuss next week. Now the sine of 44, I'm going to move that up, so it multiplies the other side. So x equals 26 multiplied by the sine of 44. All of that is going to be divided by the sine of 108. Like I said before, you need to be familiar with the calculator. I probably type this in and press equals, then divide, but there are other ways of doing it. So let's have a look what we get. We type it all in. I get an answer of 53. No, I apologize. No, I don't. I'm looking at the wrong example. I get an answer of 19.0. And that, of course, is in meters this time to 1 decimal place. Now, the actual answer on the screen, my calculator did throw me a little bit, was 18.99 and various others, but when that rounds to 1 decimal place, that is 19.0. Okay, one more example on sides. So let's have a look. Okay, now let's have a look what we've got. It's asking to find the length of side D. So we've marked side D here from E to F. So it's opposite angle D. That's kind of logical to me. But there's a bit of a problem with this question because I haven't got this angle as opposite the side. Now I need the angle opposite the side for the sine rule to work. I've got this angle of 34 and I've got the side of 43. So that can certainly help me with the question. And I've got this 102, but I've got nothing opposite it. So I've got a bit of an issue here. So this angle I'm marking now, I need to find out what this is. I need to sort of find this angle first. Now I know the interior angles of a triangle add to 180. So if I do 180 and I take away 34 and I take away 102, so I take away the two angles that I'm given, I should have an answer for this angle. So I subtract them, I am going to get an answer of 44 degrees. Now it's okay at GCSE to do workings on the diagrams like I've just shown you, and the markers will allow for that. So by marking 44 on this angle, that could possibly be your first mark in that question. Now let's go back to what we're actually looking for, which is side D. So I'm going to put D, remember whatever we're finding, I put on top, and that's over the sine of the opposite angle. And in this case, it's the sine of 44. And what other information have I got? What side and angle have I got? So I've got this angle of 34 with the side of 43 opposite. So 43 over the sine of 34. And that's pretty much the hard work done. As we know, we're going to move that sine of 44 up. So we're going to type in our calculator 43 multiplied by the sine of 44. And we're going to divide all of that by the sine of 34. And then we do all that and we'll have our answer, which again, we're going to round to 1 decimal place. In this case, the answer is 53.4 centimeters to 1 dp. Is that a reasonable answer? Yeah, I think so. That's 53. There's a 43 there. The number that I've got as my answer is definitely reasonable within the question. Okay, so there's a couple of questions on the next slide for you to try. So those questions are for you to have a go at. So it's maybe worth you pausing the video, having a go at those two questions, and I'll come back in and go through the answers. Okay, so hopefully you've had a chance to have a go at those two. I haven't got a great deal of space on my slide here, so I'm going to have to squeeze my workings in a little bit. So let's have a look. Okay, so it says here, find the length of the sides marked with a letter. So this one I'm finding K. So K comes first, and that is opposite the sine of 60, because it's the angle opposite the side that I'm finding. All of that is equal to 21, because that's the side I'm given in the question. And the angle opposite that is 43, so it's going to be the sine of 43. I'm going to do my bit of moving about. So the sine of 60 comes up as a multiply. So if you like, I'm kind of multiplying both sides by the sine of 60, but as long as you understand it comes to the top of the fraction, if you like, and times by 21, we're gonna be on a winner. So that's going to be 21 times the sine of 60 all of that is divided by the sine of 43. I can assure you my handwriting is not normally this untidy. In this case, with this little machine, it is a little bit untidy. So that's going to give me a value of k, and again, I'm going to round to one decimal place of 26.7 meters. And again, I've rounded that to 1 dp, so I'm going to write that in brackets, which is always good practice. This one, I'm finding side M. This is one of these little tricky questions again, where there's no angle opposite M. So I'm going to have to do 180, take away 75, take away 88 to find this angle, which is 17 degrees. So quite a small angle, but remember these diagrams are not drawn to scale, as it says in the bottom corner, and it should say that in your exam as well. So I'm going to find the value of M. So M is divided by the sine of 17, because it's the angle that's opposite M. And all of that is equal to the side of 13 I've been given, divided by the opposite angle, which is 75, so the sine of 75. And when I move things about, I'm going to move the sine of 17 up. All of that is going to be divided by the sine of 75 in a moment. Sine of 17. All of that divided by the sine of 75. And again, once I work all that out, I'm going to round my answer. So I've got an answer of 3.9. And that is centimeters. And again, I've rounded that to 1 decimal place. Now, I'm looking at that answer. I'm thinking that answer seems a bit small. So that answer does seem a bit small. But if we have a look at the question, this angle here is 17 degrees. So it's quite a small angle. So it is going to produce this sort of this shaped triangle. So that long length of 13, with that being 3.9, it does kind of make sense if you sort of visualize what that triangle would actually look like. Okay, so I think we're okay, hopefully now with finding the missing sides. Let's try and have a look at finding a missing angle. Okay, so I introduced you earlier to the sine rule, and we found that on our formula page, which is just the sort of first page on the inside cover of your examination. Now, the formula that it gives you does help finding the missing side, but there's no formula really given to you that finds the missing angle. So my advice would be flip it over. So flip the entire thing upside down. Now, I mentioned earlier that whatever you're finding needs to be on top. So if we're finding an angle this time, we're going to put that angle on the top of the formula, and that's going to hopefully make it life a bit easier for us. On the calculator, we need to do something slightly different. So I've highlighted there the shift button on the top left. So you need to press the shift button and then sine. And what that gives us is the inverse of sine. It gives us sine to the -1. And we always use that when we're finding an angle, whatever trigonometry that we do, whether it's right angle trigonometry or the cosine rule, which we're going to do next week. We're always going to use that shift button and then sine, or shift and cos in some cases, to find that angle. Okay, so let's go through an example together. Okay, so it says here find angle x. So there's no A, B's and C's in this question. So we've just got to sort of use our knowledge of the formula and how the formula works to help us out. So we're finding angle x there. It's been marked with an X. It doesn't have to be marked with an X. Sometimes we mark angles with different symbols. But let's have a look. So I'm going to put sine of x straight away. That sine part goes on top now because that's what I'm finding. Now, opposite x is this side here of 18 millimeters. So I'm going to divide that by 18. And I'm going to use, remember, two parts of the formula. So I'm going to look at other information I've got. I've got this angle here of 77. So I'm going to write down the sine of 77. And that's divided by the side that's opposite that, which is 21. Okay, so I want x on its own, really, because I want to solve the equation and find out what x is worth. But it's all divided by this 18, which is a bit of a pain. I don't want that there. So I will times both sides by 18. So in effect, that 18 goes over the other side as a multiply. So the sine of x equals 18 times the sine of 77. It wouldn't be the end of the world if you wrote that the other way around. If you wrote sine 77 times 18, I don't think that would affect our answer in any way. I'm going to divide that by 21, which is on the bottom. Okay, so I'm going to type all that into the calculator, and you're going to get a number. I'm going to show it in these workings, but normally I think I would just skip to the last stage. But just for your information, if you are at home following this lesson along, we type all that in, and we're going to get a number that's going to be less than 1. It's going to, in this case, 0.83. I'll chop it off there. 835 is a longer number on the calculator. But that's not the answer. You know, the size of that angle certainly isn't less than 1. So what I'm going to do, like I mentioned earlier, I'm going to do the inverse of sine, or sine to the -1. Okay, so that number, again, you need to check your calculator. Sometimes you have to press sine to the -1 and then the number. Other calculators work in different ways. So I'm just going to put I'm in brackets here just for your notes, sine to the -1, so we know what we're doing. And the value of x then, after you do sine to the -1, is 56.6. Is it millimeters? So be careful with this. It's going to be degrees because we're finding an angle. Okay. My computer didn't like that little attempt of a degree symbol. There we are. So 56.6 degrees. But of course, I still rounded to 1 decimal place. But it's the angle I'm finding and not the length of the side. Okay, so we'll do one more example of finding an angle. Now this time the notation is written in a slightly different way. So it's written find the size of angle EFG. So if it's angle EFG, it means it's from point E to point F to point G. So it's the angle that makes. And what they sometimes do is put a little roof on the F. They don't always do that in questions, but for this question, we put a little roof on the F, and that's what you're finding. So I've marked the angle there that we're finding. So let's have a look. I want to have a look at the side opposite that, which is this side EG at the bottom, but there's no information marked for that side, which is a bit of a problem. So I can't really find that side without that information. So I need to sort of think outside the box a little bit and think, what else can I do? Now I know the 3 angles add to 180. So what I think I'll do is this angle here, which I could kind of describe. I could kind of describe it as FGE maybe. So this angle here at the bottom, I'm going to find that first. Okay, so if I find this angle first, it's going to make my my life a bit easier, I think. So I'm going to find this angle. I'm going to call it theta. So theta, it looks like, I always think it looks like a little Easter egg. I don't know why. So theta is a symbol we often use to find missing angles. So I'm going to find angle theta. So my workings are going to look like sine theta. And that's divided by the side that's opposite. Remember, it's all about opposites, which in this case is 66.1 centimeters. And all of that is equal to the sine of 51, which is the angle we've been given in the question. And that's divided by 54.7. Okay. I want to get theta on its own because that's the angle I'm trying to find for now. So what I'm going to do is I'm going to move that 66.1 up. So I've got the sine of theta equals 66.1 multiplied by the sine of 51. And all of that is divided by 54.7. Now I'm going to work all of this out. And then, of course, I'm going to press sine to the -1. So sine to the -1 is going to get me the answer that I want. And theta is, let's have a look, 69.6 degrees. So 69 point, my apologies, it's 69.9 degrees. And that is to 1 decimal place. Okay, so before I give myself a pat on the back for good work, I'm just thinking to myself, I found this angle, but that's not what the question is asking. Remember, the question is asking, find EFG, finding this top angle here. Okay, so this part I'm kind of shaded in. So I haven't found that. I found the other angle. So I will have to do a little bit of a calculation at the end. So angle EFG, which is the one I'm actually trying to find, is going to be 180 degrees, which is the 3 angles in a triangle. Take away 51, which is the angle given to me, and take away the 69.9, which is this angle theta in the bottom corner I've just found. So actually, when I take all them away, I get an answer of 59.1 degrees, and that's the answer that I'm actually after. Make sure you mark in your exam what that is. So I've written EFG equals, so anybody marking your paper can clearly see that. Okay, so let's take a look. There's two questions there for you to have a go at. And again, it might be worth you pausing the video at this stage, have a try at those questions, and then unpause it, and then we'll go through the answers together. Okay, so let's take a look at these. So they're both marked theta this time. So they're both sort of unknown angles in a question that we need to find. So let's take a look at this first question. So we got this theta here in the corner. So I'm going to write sine theta. I'm going to have to squeeze my workings here a little bit because I haven't got a lot of space. But that's divided by the opposite side, which is 15. And that is equal to the sine of 45, which is the other angle given in the question, divided by the opposite side to that, which is 17. I'm going to move this 15 so it multiplies. So I can write sine theta equals 15 times the sine of 45, all divided by 17. Okay, so remember we're finding an angle. So I need to type all this in my calculator and press shift and sine, or sine to the -1. And then it will give me an answer for the angle of 38.6 degrees. So 38.6 degrees. And again, I've written that answer to 1 decimal place. Okay, this one, I'm finding theta. This is another one of these sneaky questions where I haven't got the opposite side. Remember, sine rule is all about opposites. I'm not going to apologize for repeating that because it's quite an important thing to remember. So there's nothing opposite there. So I'm going to find this angle instead. I'm not going to call this theta because I think it will confuse my workings. So I'm going to call this good old x. I'm going to find this angle x first because I've got the side opposite it. And I've got these other two sides to work with. So I'm going to write the sine of x all divided by 47 because that's the opposite side. And that equals the sine of 37, which is the other angle that's been given to me in the question, all divided by 32. Okay, so I'm going to move this 47 up to multiply. So the sine of x is equal to 47 times the sine of 37, all divided by 32. I'm going to type all this into my calculator. I'm going to press shift and sine, and that'll give me a value for x, which is 62.1 degrees. Now remember, I didn't want that angle. I wanted this angle theta in the corner. So I still need to find angle theta. So I'm just going to do theta equals 180, take away 37, take away the angle I've just found, which is 62.1. So the angle theta has a value of 80.9 degrees. Okay, so I think at this moment we've done the sides, we've done the angles. So a good place to go now is possibly look at some GCSE style questions. Now, sometimes at GCSE you'll get a question that is fairly straightforward, and the question would just be in the style of the questions we just looked at. Sometimes there'll be more problem-solving questions. So here's the first one. Now, this is only a 1 mark question. I think it's quite a nice one for us to start with. So this question, basically it's a multiple choice question. And I always say to my pupils, if it's a multiple choice question, don't leave it blank. Make sure you circle one of the answers. You know, it's better to have a complete guess than leave it blank. But of course, it's better to know how to do it and get the right answer than just guess. Have a read of the question. There's 4 possible answers. I'll just let you pause for a second and I'll come back in and explain which answer is the right one. Okay, so let's take a look at the question. So it says here is a triangle. It's very good of them to point that out. So we've been given circle the correct equation. Now, you're given 3 angles in the question. So there's no doubt at all you're not finding an angle. But they've said X centimeters, so that does imply to us that what we're trying to find is the missing side. Now, remember what I told you earlier? What I said earlier is whatever you're trying to find, try and put on top of the equation. And in this case, that is true. So they've said sine X. Well, sine X would mean you're finding an angle. So this first equation has to be wrong. This one says sine X. That has to be wrong as well. Okay, so I think it's going to be one of these two. So this one says X over sine 42. There's X there. 42 is opposite. That's looking good. Is equal to 15 over sine 104. Yeah, they're opposite as well. So definitely, I think this one's the winner. No, that's really badly circled, but you get the idea. Okay, that's the one that we've circled. And let's have a very quick look at this one just to make sure that I haven't circled the wrong one. X over sine 42. Yeah, that's right. But then 15 over sine 34. Now, 15 and sine 34 are not opposite each other. So this one, yeah, I can definitely rule it out. And I understand that is the wrong one. I definitely chose the right one with my dodgy looking circle. Okay, so here's the second exam question. I think this is quite similar to some of the questions that we've done. So pause the video now, have a go at this, and then I'll come back on and we'll talk through the question. Okay, so let's have a look at the questions asking. It tells us the diagram's not drawn to scale in case people get their protractors out and start measuring. But it says find BC, so there's angle B or vertex B, we could call it, maybe the corner of the triangle. There's C, so finding this line here, we've got the opposite angle. We've got that side there of 8.6 and that side there of 15. So let's have a look. So so we're finding that side there. We've got to find that angle. So we've got that information. Let's have a quick look. So yeah, so we'll mark it with an X just to make our workings a bit simpler. I think that's going to help us out. Remember, whatever we're finding goes on top. So it's going to be X over sine 140, because that's the angle that's opposite it. And that is going to be equal to the side that we've got, which is 8.6. We've been given that side of 8.6, and the angle opposite that, I apologize, we haven't got the angle opposite that. Let's have a quick look. Okay, yeah, so I have caught myself out here a little bit. So we haven't got the angle opposite that. So 8.6, we need this angle, and I think without this angle, I think we're going to struggle to do the rest of the question. So I've hit a bit of a stumbling block, and I realised that I haven't got this angle. So I need to do a little bit of maths here to kind of help me out, because I know again the 3 angles in the triangle add to 180. This one here is 140. This one here is 15. So I'm going to do 180, take away 140. Take away 15, so this angle here is 25 degrees. And of course, I can check that by adding them all up, and I should get 180 in the end. Okay. So now I'm just reviewing the question. I know now I have got all the information I need. So my 8.6, the angle opposite that is going to be the sine of 25. And then I need to get X on its own. So I'm going to do 8.6 times the sine of 140, and then I'm going to divide all of that by the sine of 25. Now I haven't got to use shift and sine this time, remember, because I'm finding a side, I'm not finding an angle, so I can simply type all this into my calculator. That should get the answer for X. I could have labeled it BC, but as long as the answer is clearly shown, it should be okay. So 13.1 centimeters, and then that is to 1 decimal place. Okay, so the third GCSE question is this one. There's probably a bit more information in this one. There's a bit more going on. So have a look at the question, see what you can work out, and then I'll come back on in a moment to go through the answer. Okay, so let's take a look at this. So quite often they'll give you a lot of information in the diagram, and then they'll kind of repeat that information in a written form. So it says you're given that BC is 6.6, so B to C is 6.6, yes it is. AC is 8.4, yes it is, and ABC is 6.2. So ABC is 6.2. Now that sort of sentence agrees with the diagram, and I'll be honest, at this stage, I would probably it's gone forward one again, I apologize. At this stage, I would probably disregard that sentence because all the information is there. Okay, so everything is there for you. Calculate the size of acute angle BAC. So B to A to C. So it's asking you to find this angle here. I think instead of writing BAC every time, I'll call it X. Remember, I can call it whatever I want, really. So I'm going to do the sine of X. I've written the sine not in full, but it doesn't matter. The sine of X divided by the opposite side, which is 6.6. And all of that is equal to the sine of 62. Ooh, that line's gone a bit crazy. Sine of 62, all divided by 8.4. Okay, now I need to get X on its own, so I'm going to move that 6.6 up. So the sine of X equals 6.6 multiplied by the sine of 62. And all of that is divided by 8.4. Oh, dear me, sorry. Yes, it is. Yeah. All that's divided by 8.4. So I'm going to type all of that into the calculator. I'm going to press Shift and Sine with the inverse of sine. And I should get an answer for that angle of 43.9 degrees. And that is to 1 decimal place. Okay. We're running a little bit short of time, so I'm just going to skip over the next exam question, and hopefully that will bring us nicely to the plenary. Okay, so let's just double check what we've learned. So we've gone through the formula, and what I mean by the explanatory notes, as I mentioned earlier, is the little triangle picture they draw for you, which kind of labels the capital A's and the lowercase a's, b's and c's, and tells us what is what in the formula. Hopefully you understand the use of sine button on the calculator. We've used the sine rule to find missing lengths in the triangle, and we've also used it to find missing angles. So that brings us to this final question. Okay, so I'll talk through the question. Again, I'll give you a moment to have a look at the question on your own to see what you can work out. And as I always say to my classes, it's better to do something than to do nothing. So even if that something means labeling the diagram, finding some maybe missing angles without finding the final solution, it's always better to do something or do part of the question than do nothing at all. So this question I've written, but as a GCSE question, it may be worth maybe 5 or 6 marks. It's a fairly complex question with a little bit of stuff going on. So let's have a look at the question. Then I'll pause for you to have a go. So 3 Welsh towns are shown below. So you've got Haverfordwest, Narberth and Tenby. And then you're given a sort of list of instructions or some notes to kind of help us along. So it says Narberth is due east of Haverfordwest. So that's quite important to know. If you're from that part of the world, you may know that. But one town is pretty much in line with the other and it's due east. Tenby's on a bearing of 123 from Haverfordwest, which is marked on the diagram. So that 123 degrees. And remember, bearings are always measured from north. My pen working again. So bearings are always measured from north clockwise. So there's that bearing of 123. And Tenby's on a bearing of 170 from Narberth, which is that bearing that's given to us there. It also tells us Narberth is 15 kilometers from Tenby. So there's 15 kilometers marked there. We need to find the distance from Haverfordwest to Tenby. So I'm going to mark that distance with an X so you can kind of have a look at what you're finding. That's the distance that we need to find. It might be worth pausing the video now, having a go, but remember what I said, please. Let's see what you can do. Okay, so it's always better to do something than just leave the question blank. So have a go at that, and then I'll come back on to go through the answer. Okay, so let's take a look. So I think the key thing here is there aren't really any angles within the question, or I should say there aren't any angles inside the triangle. Now, of course, that triangle isn't really there. We're just talking about a distance. So the triangle isn't physically there. That's why I've used the dashed lines, but there's no angles inside it. And I think we need to introduce some angles to help us out. Now, we know that the bearing is due east from Howth west to Narberth. It says that in the question. So I know that this part is 90 degrees. So 90 degrees is from the north arrow to the dashed line that I've drawn. Now, if that's 90 degrees and the whole bearing from Howth west to Tenby is 123, we can subtract them, and we know this angle, which I'm just going to mark in red here, this angle here is 33 degrees. So all I've simply done is 123, take away the 90, which gives us a bearing of 33. Now, what else do I need? Now, that 33 is quite useful to me now because I've got the opposite side. But I want to find this side X. So I need this angle really where I'm indicating here. So I'll draw it in. This is the angle I really need to help me solve the question. Now, I know this is 170. That bearing is 170. That's given to me. But then I also know the bearing kind of from Narberth to Howth west is a westbound bearing because it's kind of opposite Howth west and Narberth, which was an eastbound bearing. So this one here I know is also 90 because that makes up a right angle between the north arrow and that line. So we know angles in a full turn make up 360 degrees. So if I do 360, take away 170, take away 90, I'll have this bearing here, which is 100 degrees. I said bearing there, that's slightly incorrect. It's not a bearing, it's an angle. Remember, bearings are always measured from north. So it's not a bearing, it's the angle there within my triangle. Now I've got that information, hopefully I'll be able to solve it. So let's go back to what we're trying to find, which is X. So whatever you're trying to find goes on top. So X is what I'm trying to find, and it's opposite the angle, which is the sine of 100. And we have a look at what other information we've got. We have got this side here of 15 kilometers. So 15 goes on top, divided by the sine of 33, which is the angle that's opposite the side that's been given as 15. Now I'm trying to find X, so I move that sine of 100 up. So X equals 15 multiplied by the sine of 100, all divided by the sine of 33. Remember, it's a side we're finding now, so no need to press shift on our calculator. It's simply 15 multiplied by the sine of 100, and then when we get our answer, we can divide that by the sine of 33, and we should get an answer of 27.1. The units are kilometers, and again I've rounded that answer to 1 decimal place. Okay, so hopefully that makes sense. Just to recap with this question, the maths involved with finding the side of 27.1 is pretty much what we've done over the last 45 minutes, but there was a bit of extra work we needed to do, just sort of working out the angles within the triangle. Okay, so that comes to the end of today's session. Thank you so much for joining us. We will be running these weekly for the next 3 weeks after today. Back to you, Mrs. Dixon.
Thank you, Mr. Casey. I hope you all found today's session useful. Session 2, next week's session, will focus on using the cosine rule, and we hope to see you then. Bye.